to Engineering Hotspot. Hope you are doing well. First, I like to apologize for the question that we have included in the part 1, that is question number 4. The solution that we have provided, that was wrong. So we are providing the new solution so that you can understand where the problem was. So let us begin with the question. So question number 4. A simple compressible substance inside a cylinder undergoes the change of state quasi-statically, isothermally and at constant pressure of 1.5 MPa. If the enthalpy change for the system is 4000 kJ at 150 degrees Celsius, what is the corresponding change in its entropy? So you need to take care of the question here. They have given a compressible substance, okay, and one more thing is quasi-statically, one more thing is change of state. This is carried out isothermally and at constant pressure. So these are the important key points in this question. So let us begin. First, I like to start with the basic equation. We know del Q is equals to del W plus delta H. Okay, since Q and W are path functions, they are inexact differentials, so that's why I am including here delta, whereas enthalpy is a property. Change in enthalpy is a property, and so that's why it's a point function, and that's why it is D. So plus if you write the complete thing, it will be plus delta AE plus delta PE also. But here nothing is given about the change in kinetic energy or potential energy. So you have to neglect this term. Now, you know that delta Q is equals to TdS. When you can use this? It is only in case of reversible process. And similarly, del W, dou W is equals to minus VdP. Integration of VdP. When you can use this process? It is also for a reversible case. So, see, in this question they have given quasi-statically. Quasi-statically means you can assume the quasi-static process to be, quasi-static basically means very slowly, and you can treat that process to be reversible. So, you can apply these relations. And moreover, they have said change of state. Change of state means, suppose I am taking initially the substance was at this position. This position means it has a pressure of P1, volume as V1 and temperature as T1. Now it has changed its state and it has acquired the temperature, pressure as P2, volume as V2 and temperature as T2. But here there is one more thing. They have said the process, the change of state is isothermal. So that means T1 is equals to T2. And they have also said the pressure is also constant. So P1 is also equals to P2. That means volume is changing, and volume will change because it's a compressible substance. The volume will not remain constant. Now let's see what you can write here. Instead of del Q, you can write TdS because it's a reversible process. And instead of writing tau W, replace it with integration of V dP. And this is delta H. Now you see they have said that it is at constant pressure. So what will happen? This thing, this del P will be equals to 0. Del P is equals to 0. So you have to neglect, this will be 0. This thing will be 0. So you will be left with TdS is equals to delta H. Therefore, delta S is equals to delta H divided by T. And in this question, they have mentioned the enthalpy change of the system. The change in enthalpy means delta S they have given. They have given this value as 4000, and they are not giving you the sign. So it's considered as a positive only. So 4000 kilojoule. And your temperature they have given this change is at 150 degrees Celsius because the temperature is kept constant. So they have given the value of T as 150 degrees Celsius. So it will be converted into Kelvin because you have to take in absolute system only. 273. So it will be 423 kelvins. 423 Kelvin will be the temperature. Okay. So now substitute this temperature here, 423. Now if you ask me how you should solve this calculation, so you have to look into the options. See, if you take this 423 approximately 400, it will come around, this result will come around 10. But this quantity in the denominator, you can see it's 423. It's greater than 400. So this value will be less than 10. So something close to 10 but less than 10 will be less than 10. So there is only one option left with you out of this 4, that is 9.45. So this will come to be 9.45. This was in kilojoule and this was in Kelvin. So kilojoule per Kelvin. So this is the correct answer. I like to add some important informations like why I have not treated why I have not used this equation that I have used last time. So let me clear this. See, last time we have used delta S is equals to Cp into ln of T2 by T1 minus R into ln of P2 by P1. But remember, this equation we cannot apply in this situation. The reason is this is applied only for an ideal gas, applicable for ideal gas. Ideal gas. Okay. And here they have just mentioned it's a compressible substance. The substance can be anything. It can be solid, liquid or gas. we don't know, and they have not mentioned it's an ideal gas. We cannot treat it to be ideal. It can be real also. So in that situation, we cannot solve using this equation delta S is equals to Cp ln of T2 by T1 minus R into ln of T2 by T1. Otherwise the answer would be 0, but in this situation it will not be 0 because you have to solve in this way. This will be the correct approach to solve this problem. And one more thing, PV is equals to nRT. This equation you used to apply, but this is applicable only for an ideal gas, which you cannot apply here. So this you have to keep in mind. And one more thing, that if you are considering solid, the substance to be solid, in that case you can directly write delta S is equals to C average into ln of T2 by T1. But since we are not knowing whether it's solid or liquid or gas, whether it's solid, so we cannot apply this equation directly. C average is basically the average of C. C means specific heat capacity for in compressible substance. Cp and Cv are almost equal, like for solids. Cp and Cv are almost equal. So but C will change with the temperature. But for real gas, C depends on two things: pressure as well as temperature. Cp and Cv are functions of pressure and temperature for real gas, while delta H is function of P and T. It is also the function of P and T for real gas. These points you can keep in mind. And delta U is function of volume and temperature for real gas. So these are some important things which you can keep in mind. So one more time I am repeating that it is not, they are not mentioned which type of substance is that. They have just mentioned it is a substance. They have not specified that it's a gas or it's a liquid or it's a solid, and they have not mentioned that you have to take it ideal or something like that. So we cannot use this concept, but you can apply this equation, and this equation, since they have mentioned it's a quasi-statically, so you can treat it to be a reversible process, and then you have to solve in this approach, and finally you will get 9.45 as the correct answer. So thank you friends. If you feel any doubt, please mention us, and no need to challenge this question because as per the ISRO answer sheet, the answer given was correct. So thank you.